There we go. So welcome back to our last Tuesday together. Happy Garbage Day to those of you who are celebrating, got my merch on. I've been encouraged to pursue NIL, name, image, and likeness. So looking for other ideas for merch, why not? But speaking of ideas, I'm ready to play Let's Make a Deal with you all. Who wants to play Let's Make a Deal with me? You all want to play, trust me. Okay, so here's my deal. I have two deals. Of course, I was logged out. So what I have open are my course evaluation numbers. These are open until Saturday night, I believe. These are the university-sanctioned course evaluations. As you can see, I have only 6 out of 23, which is woefully lower than all of my other previous response rates. And you know how I got response rates that are this high? Bribery. That's correct. I bribe people. So that is my deal for you. There are 23 of you officially registered in this class. If at least 21 of you complete a university course evaluation, everybody gets a full point of extra credit. And it's actually a better deal because it's out of 88 and not 100. So it's slightly more than a percentage point.
Isn't that sampling bias, though?
Sampling? There's no sampling error. This is my point estimate.
That's true.
1. That's what I'm offering. I'm not willing to do the math to figure out in decimals like how much of what a real point would be. It's just going to be 1. So that's deal number 1, okay? So university course evaluations, if I get a course completion rate of at least 21 out of the 23 of you, everybody gets a point of extra credit. So I will find that out on Sunday. It closes Saturday night. But because the university does not let us change any of the questions to be asked, and I find their feedback to be less helpful because it's less specific, I also do my own. So here's deal number 2. After class today, you are going to get an email from Qualtrics with a link to a custom survey about your experience in this class. The way that it works is that I fed Qualtrics a list of your emails, and it tells me which emails have completed a survey, but it doesn't tie your responses to your emails. So each one of you individually who completes a Qualtrics survey will get another point of extra credit. So up to 2 out of 88 for providing course feedback. Now, that being said, you can write whatever you like. If your feedback is, I hate you and I hate this course, you still get your 2 points. So I'm not buying good evaluations. I am buying a response rate, okay? To be clear. I hope, though, that if you decide that you want to tell me that you hate this course, that you will tell me why. Because then I can't fix it if I don't know what the problem is. So that's why I'm asking a number of specific questions about various elements of the class as well as open-ended, do you have anything else you want to say? And I do make changes based on the feedback when it's possible for me to do so. I also added a question about your experience with the TAs. I remembered to do that this year. Yes. So any feedback that you provide to that question, I will just lump together in a chunk of text and share it with them. That way there's no, we're trying to keep it anonymous, so to speak. So since I know that some of these people are your friends and classmates and maybe even relatives, right? So maybe. So that's my deal, all right? So recapping, course evaluations through the university. 21 out of 23, everybody gets a point. Qualtrics evaluation invitation coming after class today. Each person who does that gets a point, and I'm leaving that one open until the end of finals week, so you don't have to rush through it. Okay? All right, so on Thursday, I'll pull this up again, and we will see where folks are at. Other announcements, I finally finished developing all the course materials for this semester this morning. Woo, me! But I ran out of gas because we're running out of time. So I have a lecture that we're going to go over this week, and I have examples that I did not build a separate handout for, but I have syntax and output in all 3 packages to do various things. I think at this point, you probably don't need the annotation as much because you know what you're doing and you've seen the software before. So I wanted to give you some examples, but we're not going to have a time to go over a full-scale handout, so I did not build one. But I have all of that stuff. And I also added, to those of you who have not submitted homework 4 yet, please do it by Friday. After that, I cannot guarantee that I will grade it in time for a revision. If you get it to me by Friday, I will turn it around over the weekend so that you'll have next week to work on it. So ollie ollie oxen free, as we used to say. I don't even know what that means, but it's what you say when everyone's playing hide and seek and you want to end the game and you're telling people to come out, ollie ollie oxen free.
Good old my father's apple tree.
Okay, I did not know that part of it.
Okay,
Yeah.
yeah.
Okay, so ollie ollie oxen free to those of you who are hiding from me because you haven't finished your homework. All right, just give me something to react to so that you can get a chance to revise it. Next week, nothing but office hours. So extra catch-up time if you want to get help with things. I'm also available for individual meetings over Zoom if that fits your schedule better. Let me know. All right, let me think. Is that? Yeah, I think that's all the announcements I had. So what we're going to do today then, go over formative assessment number 6, start lecture 8, and then you can be working next week on finishing homework 4 revisions and finishing homework 5/6 or 7. Any questions or comments? All right then. How about we talk about our formative assessment? I updated grades this morning, so you should be able to see that you have all of your quiz points. First question, what 2 problems that would be encountered in general single-level or multi-level models are generalized models designed to solve? Most of you wrote this correctly. How about you? What do you got?
So when you have non-normal conditional distributions,
When you need one.
or
Yep.
yes.
Yep.
And then the logit link keeps the outcome values bound where they're supposed to be. Like you don't go beyond the 0 or 1 or
Yes.
whatever you're binding it to.
Yes, so that's a specific example for binary. But the idea of a link function in general solves boundary problems. So if you have an outcome that has endpoints that it shouldn't go past because it doesn't make sense for that variable, link functions are designed to solve that problem. So logits are designed for variables that have 2 boundaries, upper and lower, 0, 1 data, proportion data. Other kinds of data where there's a ceiling and a floor can be transformed to become within a 0 to 1 space, and logit links can be used for that. Probits would be used for that. Log links are used for things that can't go negative. There's other link functions that are out there, but those are the ones that I see most commonly. But link functions in general are designed to make sure that predicted outcomes stay within the bounds of the possible outcome scale. So that's one problem. The other, distributions. So lots of you wrote about not normal. The idea of normal is not as important as the idea of constant variance in this context. So the problem with normal is not the shape. It's the idea that in the normal distribution, there's only one parameter for variance and it is separately estimated from the mean. So that means that variance is assumed constant regardless of where you are on your predicted regression lines. For data that have boundaries, outcomes that have boundaries, that can't happen. The closer you get to the boundaries, the variance is going to shrink around it. So we need some kind of non-constant variance that's a function of the predicted outcome mean, and that is solved in other kinds of distributions. So Bernoulli is for two choice outcomes where there is no separately estimated variance. Multinomial is for more than 2 categories, but also still categorical. When you get into count data, for instance, Poisson negative binomial, the variance grows with the mean in negative binomial. Quadratically, it grows straight with the mean in Poisson. So not constant variance is the big one that goes with that. So generalized models, whether they're in single-level land or multi-level land, solve those 2 problems. That's the change. Then you can just use your regular fixed and random effects like normal. And in case you haven't heard me say it enough, teaching a whole class on that next semester. So if you're like, what the hell is a logit again? Come back in the spring. We'll talk about logits some more. And if you're taking SEM in the spring, we're going to talk about logits some more too, because factor analysis on categorical outcomes is a thing. Question 2. In what situations, i.e. sampling designs, would you need a multi-level model with crossed random effects at level 2 rather than strictly nested? So lots of different answers for this one. I intended it to not be in a psychometric context, so maybe we can talk about that version of it first. So if you have clustered data, people nested in groups of various kinds, when would it become a crossed model and not just a nested model?
kind of public or private school, whether that was like elementary or middle school maybe or something,
Mhm.
and some students have gone to both types, right?
Yes.
But then while others have just been a part of one.
Yes, so the example given was students who belong to more than one kind of school. So what elementary school they went to creates a clustering. What middle school they're in right now creates a clustering. What high school they're in, that kind of thing. Yep. Several of you told me about schools and neighborhoods. Same idea. What about within a university setting? Nikki, I'm going to call on you.
Students potentially in 2-degree programs.
Yeah, students nested in majors at the undergraduate level or at the graduate level, as it were. Students nested in dorms. That's a thing, right? Do you think who your roommates are might have some sort of relationship to your outcomes potentially? No, not time for stories. But just, think to yourself. Do you think there's an extra correlation of students who live on the same floor and have the same major, so they're studying for the same classes and around each other all the time? Possibly. What about in medical settings?
So you could have like patients see the same doctor, or like doctors could be at a hospital one day, a free clinic the next day.
Mhm. Yeah, so doctors and clinics could be crossed if doctors work at multiple clinics, or people might go to multiple clinics and see multiple doctors. Yep. So there's lots of examples of this in real life organizations. The big idea is that if people belong to more than one kind of cluster at the same time, that's a crossed model. If they change their clustering over time, that's also a crossed model. So what classroom were you in at time 1? What classroom were you in at time 2? That kind of thing. That's crossed. Big picture stuff. That's all I wanted to say about that. That's big picture stuff. Questions? Other examples that you thought of? All right. Question 3 then. And I'm going to have a bonus question 4. I already decided, by the way. I know, but what? Yeah, I'm going to ask the big one. In multi-level models predicting multiple item responses for multiple persons, so the psychometric example, when do you need a random effect of items in addition to a random effect of persons? You can answer.
If it's assumed that there is local independence, so that the only, if you have an item response function that's conditional on ability, and ability is the only thing that varies between, or that you're allowing to have a random effect,
Mm-hmm.
then you would have person level random effect, and then I think I'm halfway there.
You are halfway there. If you only put person in as a random effect,
Mm-hmm.
then you're only allowing a correlation of item responses from the same person.
Mm-hmm.
You're not allowing a correlation of item responses from the same item, which may be needed. When do you need that? Multiple items trying to measure the same thing. And what about the fixed effects? How do they play in? Like if I have item features, like whether the change is relevant to driving, or whether the paragraph has a story about this in it versus that.
You need a reference, whatever the reference is compared to that.
Mm-hmm. But what if I want to test those kinds of predictors? If I want to predict why things differ in difficulty or easiness.
That's another reason that you need a measurement intercept, so that you can basically include it in the equation to predict the outcome.
Yep.
Because otherwise you can't implement the equation.
Yes. Yes. So if you model your item responses as fixed effects, meaning like every reading passage gets its own difficulty, then you don't have to worry about a random effect because the fixed effects soak up all the variance. But if you want to replace, like whether it's picture 2 or picture 3 or picture 4 with characteristics of the pictures or the stimuli, that's what I'm talking about, then you need the random variance left over so that you can judge how much of the variability your features explained. Yeah, so anytime that your items are not exchangeable, that they could potentially vary in ways that you did not anticipate and build into your model. So if you only have 4 items and you put in which item is which, you're done. But if you have 4 kinds of items and there's 20 items of each kind, you're not done. Because items of the same kind may differ in other reasons besides the ones that are in your model. And so there may be item dependency. And this is true, a couple of you wrote about items being binary responses. This is true regardless. This is a universal concept whether your outcome to the items is binary, categorical, continuous, what have you. This is, the estimation gets trickier if it's not continuous, but it's the same principle. All right, there, question 3. Now question 4, as promised. We'll look at the beach for a minute here. So one of the things that happens periodically when I teach stuff is people come back to me and say, well, I talked about what you said with my advisor, my colleagues, my peers, whomever, and they told me that I'm wrong because. So let me give you a very common thing that I see people say, and how would you respond to it? I have clustered data, the kids are nested in classrooms, but I don't have any research questions about the classrooms, so I don't need to worry about it in my model. That is correct.
And then I'd walk away. I'm not very helpful.
Okay, so if you wanted to be helpful, how might you convince this person to think about the problem differently?
So I might phrase it as a question, and I'd be like, so are you assuming that all classrooms are the same and all kids in the classroom are equal? And I'd imagine they would say, well, no.
Well, no, but I don't care would be the follow-up, right? I know they're not equal, but I don't want to care about that. Yes, Zoomers say your model is wrong, no matter if that's your research question. That's how I'm pronouncing the tilde around wrong, by the way. I think that's an emphasis mark. So,
Like, basically, just because your research question isn't about group differences doesn't mean that those group differences couldn't potentially impact the things that you do care about. So you should incorporate it into your model and test whether or not, like, the variances go down and things like that. At the very least, you know, yeah.
agreed 100. The not controlling,
All of sociology.
not controlling for the clustering could change the answers to the things that you do care about. So what are the specific problems that you would run into from ignoring clustering? What about design effects? Remember those from the very beginning? Standard errors are wrong, probably way too small, because your people are not independent.
Smushed.
That's another one. What about contextual effects? So you're only interested in people variables, good for you, but is a people variable just a people variable?
No.
Not usually. It's at least a little bit of a contextual variable. What if can I just do cluster corrected standard errors and call that good?
Depends on how okay you are with being wrong.
Depends on how okay you are with being wrong, yeah. So they fixed the design effect. They fixed that part. So the job of cluster corrected standard errors is to render the standard errors into what they should be as if you had actually built a random intercept into your model. It's like a mathematical sort of after the fact post hoc correction-y thingy. Yeah, that's a very technical description. For a better description, I would read the McNeish article that's in press. It's a super long one on your reading list, but he talks about these 3 approaches to dealing with clustering. But does it deal with contextual effects if you do that? No. So you would end up with a correct standard error for a smushed slope. And that, I don't know what to do with that. What could you tell people to do to solve the problem if they really, really didn't want to learn multi-level modeling? Like, my paper has a revise and resubmit, and I just need to answer reviewer 2. I don't want to redo my whole analysis.
Control for the clustering, like with a fixed effect to
Yep.
different kinds.
Throw in cluster ID as a predictor. Fixed effect it out. Then do we have to worry about contextual effects? We don't, because the fixed effects of clusters soak up all the cluster variance. There's nothing left over for the contextual effects to have predicted. So you can't have which cluster is which and the mean whatever of the cluster. It's redundant. Which cluster is which knocks it out. So that's one thing you can do. Another thing you could do is to cluster mean center your entire data set. Outcome and predictors. Literally remove all of the cluster mean differences from the analysis before you get started. So that's what I would tell them to do. How much of a problem it is, how wrong it is going to depend on the situation. So if we go back to kids in classrooms, what if the outcome was something like student self-confidence as answered by the students? As we discussed last time, little kids think they are awesome at everything, so that won't be a variable, that will be a constant. But even if there is a little bit of variance, do you think that has to do with what classroom they're in? Maybe not a whole lot. What if the outcome was teacher-rated student self-confidence? Oh, yeah. Do you think who filled out the survey matters? I don't see how it can't. In other types of medical situations, for instance, if you're not interested in which provider it is, but you want to study something like tendency to over-medicate, might there be provider differences in a tendency like that? For better or worse. So yeah, just because you're not interested in research questions about the clustering doesn't mean you don't get to care. That, if you learn nothing else this semester, learn that. But not everything does have to be a multi-level model. There are alternatives. And for those of you who are pursuing complex analyses already, like latent variable modeling or longitudinal modeling or some combination, and you have clustering, I would probably suggest the fixed effects or some other way of dealing with the clustering that makes the model not even worse by adding levels of variance. It all depends. That's my question. Do you have any questions for me? Like things you want to talk about?
Hey Lisa, I have a question for you.
Okay. You turn it
It's just about can you hear me?
Yes, now I can.
Sorry. It's just about multi-level modeling in general. My friend is an epidemiologist, and when I was listening to her dissertation, she had a bunch of states, and she just did a single level model, and I just kept thinking in my head, like, oh, you should be like doing a multi-level model, like within states. And she was actually the one, she was really impressed. She's like, you know, Dr. Lisa Hoffman, because she had heard of you, but she heard of you, and she's at University of Arizona, by the way. So not even in the same state. And she's like, yeah, no, I was starting to read her book, but like starting to look into your stuff, but it was like a month before her dissertation was due, and she's like, yeah, I'm done. And,
Yep.
and so she was saying how multi-level modeling is not really like seen in epidemiology, like it's just not within her field. And so I was wondering, how many fields are like that? Like, is this a newly, like within the last 5 years, or like fields aren't open to it, or like what is the background with that, if I can ask?
Yes. So
Okay.
there are a number of fields in which random effects models are just not a thing. Econometrics, certain parts of, I don't want to say sociology, but sort of like heading in that kind of like political science, like organizational stuff, some of that. She may be controlling for states via fixed effects. There are models that have special names where that's what's happening under the hood, and it's not evident from your syntax or your output that you're actually doing that, because they don't even show the fixed effects in the output. So if she were doing something like that, then she probably doesn't need to worry. But yeah, there are areas in which fixed effects are preferred and random effects are considered suboptimal, or you would have to justify your choice of random effects. There are 2 articles on your reading list about that. These 2 right here posted in week 4. Those are discussing how the concerns about smushing and multi-level modeling are exactly the same concerns as whether you should have fixed effects versus random effects in these other disciplines. There is a mathematical equivalent. They're both worried about the same issue. So the random effects models are fine so long as your model's not smushed. then you have a problem, because level 2 is not properly specified in the model. That means that your level 1 predictors can still be correlated with your random intercept, which breaks endogeneity. So yeah, multi-level models did not become commonplace until like the late 90s. So that's another thing, is that if those fields are not yet using them, then that could be an issue, but that was a long time ago. So I would hope that things have changed since then.
Yeah, I was just surprised I didn't see it in her dissertation how she laid it out and explained it. It didn't seem like there was any sort of control for it. And I was wondering, and like for the professors not to say anything, I was just wondering if they just were oblivious or if, I don't know, just wondering. It's been bothering me, and it was like in spring when she gave it. So just wanted to ask. Thank you.
No problem. And I don't want to throw shade on those professors, because like quant is its own area, right? Like we have our own journals and everything. Like that's the research that I try to keep up to date on. But those of you who are majoring in other areas, right, you have your own journals and research you're supposed to keep up to date on. And you're trying to learn all of this stuff too. So if you are a faculty member and you have your own active line of research in your thing, I think it's unreasonable for you to be a methodologist at the same time. Like to do 2 jobs at once is very hard. But then you would want to make sure that your student has access to people who can help them. That's not your specialty, and that's why committees are so important, to think about what are the expertise levels and types that you need and build it around that. So comment from the Zoomers. We have somebody over at CPH. What is that?
College of Public Health.
Okay, College of Public Health, thank you, who is becoming a champion of MLM and had an EPI student use MLM for their dissertation. So, and Maddie is trying too, our medical student. So yes, you're in charge of bringing multi-level modeling to the College of Public Health, okay? You. Yeah. Not that I'm being unrealistic or anything, but graduate school is like your last chance, I think, really to spend a lot of time learning new things and not have it take over the rest of what you're supposed to do. Like once you're a faculty member or you have a 9 to 5, it's really tough to be 2 things. That's why I'm not a cognitive psychologist anymore. I couldn't stay. So, keeping it real. Other questions? Things you want to talk about? Review? Yeah.
Yes, there are 2 things that I would like to have references at least, or
Back to the beach.
examples.
Okay.
Yeah, one of them is about missing data.
Oh.
How to deal with missing data. Maybe you have some examples in the multi-level context. How should we explore that thing, and how could we do to try to fix some of the problems that we have related to missing data, specifically in the multi-level context. And the second is about how to analyze interactions when we have 3 levels, especially because I was reading the material and there are some things which are like hard to digest. So examples or references about
Okay.
those 2 things.
So about missing data, I would say that what is actually scheduled for Unit 8 here, the multivariate approach, would be the easiest, most straightforward way to address missing data. You bring any variable that has missingness into the likelihood, it thinks it's an outcome, and then you can have missing observations on it the same as any other outcome. So fitting a multivariate model using SEM type software would be the easiest way to do that. If you are going to do multiple imputation, which is a process by which you predict what the missing values would have been, but you don't stop there, because that's cheating. It is. Like you can see single imputation, like fill in the mean types of options in software. Never, ever, ever, ever do that. Because everything looks too good, right? If you put in the right answer on the regression line, how can that not be cheating? So instead what you do is you fill in, the software fills in missing values that are predicted based on the information you do have, but then it adds error. It draws a random error and sticks it on there. And then you do the same thing multiple times, like 50 times. You build 50 complete data sets, each with a little bit of error added to the missing value, and then you run your analysis 50 times. And then you combine all the results paying attention to the variation across the 50 as well as the standard errors within the 50, and there are rules and procedures for doing that. Now that sounds like a pain in the ass to me, so I've never ever done it. But if you're going to do that in a multi-level context, you would have to make sure the imputation understands that you have levels of analysis. So if you fill in missing values without recognizing the dependency in them, right, that's a problem. So it has to be a multi-level multiple imputation. If you want to go Bayesian, that is a nicer approach because you can fill in the missing values and add error as you go, and it's not a separate like multi-stage analysis, it's through and through. And Jonathan is thinking about teaching a missing data course this fall, so maybe you should go to him and beg for him to do that, because that'd be the next option is it needs a full course, but I don't have the degrees of freedom to do it.
Okay.
So the other one, the interactions.
Yes. 3-level models.
You can have interactions within or across any levels with respect to your predictors. So is there a more specific concern?
Yeah, to me the thing is how those cross-level interactions, because I don't remember if that's in the slides or maybe in one of the book chapters we read that they said that we could even include random slopes for the interactions
Yes.
across levels. So all of those things related to interactions and multi-level model to me is hard. So maybe you have references to read about this with specific examples, with some data, just to try to understand how this works.
Yes, so I put in a tutorial about centering in 3-level models here, and then chapter 11 of my book is a 3-level time within person within cluster type of example. But yeah, you can have technically speaking, in the models that we've seen, we could have random interaction terms too. I've never done a level 1 interaction as part of an example, but that could vary over clusters as well. But if you want to have a random interaction, do you know what you have to have with it? Random main effects. So then you're talking like 3 random slopes at a minimum to do that. And that's tricky. Cross-level interactions would work the same way. They explain the random slope variance of the predictor that's part of the interaction if it has it, or residual variance if not.
Okay, I will read those.
Yeah, other than that, that's all I can say sort of in a generic way, but these are a couple of resources. 3-level models are harder to come by. I have a couple slides about them that hopefully we'll have time for on Thursday.
Great, thank you.
All right, others? Want to talk multivariate? The latent centering thing, remember that? Like I told you about that like 2 months ago and then it just disappeared. It's back. Centering's back again. The finale. So, a little bit of review, setting up the stage for why we would want a multivariate model then. 3 kinds of slopes that any level 1 predictor can have within. So this is the idea of you relative to your peers. If I have more X than other people in my cluster, do I have more Y than other people in my cluster? If so, that should explain level 1 residual variance for my outcome. The between effect, if I'm from a cluster that has a higher mean value of X than other clusters, does my cluster have a different outcome? If so, that should explain level 2 random intercept variance in your outcome. And then the contextual one. And there's 2 different ways to think about this. Does the cluster mean still contribute after controlling for the individual predictor's effect? That's the more natural, I think, interpretation, substantively. The more statistical interpretation is as a direct test of whether the level 1 within slope differs from the level 2 between. So these are still the 3 things that we're after. The question is how we can rearrange our model to get them there. So here's what you know. Cluster mean centering, otherwise known to me as variable centering because you're subtracting a variable. If you do this to your level 1 predictor, you will end up with level 1 within slopes and level 2 between slopes at the end. Do I need to ever think about this for level 2 predictors in a level 2 model? Nope. Can I cluster mean center a cluster thing? Nope. What if I had a 3-level model? Then could I cluster mean center a level 2 predictor in a 3-level model? Yeah, 3. Yep, hierarchical, yep. If I had a 3-level model, level 2 predictors could be centered at the level 3 means. But the top level, you can't have cluster mean centering for. There's nothing above it to form the mean. Other option, constant centering / grand mean centering, subtracting a number to change what 0 means, but otherwise leaving the variable intact. If you add in the cluster mean, then you end up with level 1 within and level 2 contextual. If you don't put in the cluster mean, you end up with smushed. And what's the nicer way to say that?
Conflated.
Conflated. Yeah, that's the more professional version, but I'm trying to make smushed happen. And I've actually read a couple papers where the subheading was like something smushed effects. I was like, that's mine! I did that! So, I don't think writing has to be boring, but if you feel silly writing smushed in your papers, then write conflated or convergence instead. I don't like the alternatives of total or composite because those words are too generic and they could mean a lot of things. Conflated is my second choice. So if you don't put in the level 2 mean and you're in this method of centering, then you end up with smushed effects, and that is wrong. So these are the 2 that we've beaten to death this semester. Your last homework features 1 variable of each. Not trying to be mean, but just really trying to drive it home. That how you set up your model is up to you, but this controls what kind of level 2 effect you get back. Here's the third one that we haven't talked about yet, called latent centering / multivariate / multi-level SEM. You let the model carve it up for you. You don't make observed variables, you let the model do it the same way that it's already doing it for the outcome. So if this is cluster mean centering, in which we make a level 2 box out of the mean across people from that cluster and center it at a constant, the level 1 box, we take the original level 1 predictor and subtract the level 2 mean so that it only has within variance. This is constant centering. So here we still have a level 2 box, but it fills in the difference of what the level 1 box contributes. So this is the idea of contextual over and above what is already implied by the level 1 predictor. These 2 predictors are correlated, which means their unique effects in the model become different after they're paired together than if they're before. Hang on. If you're going to, so this is recapping that, if you want a random effect, which way do you need to do it? Only one of these is okay. If you want to have a random effect of a level 1 predictor, how should it be centered? Cluster mean, always. There is no easy way to unsmush it. So you've seen this before, but just to remind you what the problem is. If you introduce a random slope, what you are introducing behind the scenes is heterogeneity of variance in a quadratic pattern across the level 1 predictor the random slope is for. If that level 1 predictor is the constant centered version that has both its level 2 part and its level 1 part, you are saying that same U-shaped pattern of heterogeneity holds at both levels. So it's like a smushing problem. However, to solve it, you would not want to try to estimate a contextual random slope. It is a thing, and it breaks my brain to try and explain it that way. But technically speaking, you can have a random slope of a level 2 predictor. It's not a random slope in the way that we're used to thinking about it. It's really just a heterogeneity component. Here's the article that I assigned that is in press right now that explains this problem in more detail. So my advice would be to just always cluster mean center or do the multivariate approach that I'm going to show you today. So here's the third option. We let the model partition X in the same way that partitions Y. In order to do this, we need software in which we can predict more than one column at the same time. So at a minimum, we would fit an empty means random intercept model for X. And if you're going to use it as a predictor, I would center it ahead of time so that 0 is meaningful. Then what's going to happen is that rather than having the cluster mean at level 2 to represent its between cluster variance, we're going to have a random intercept for X in the same way that we have one for Y. Likewise, rather than represent within cluster differences via the cluster mean centered level 1 predictor, we're going to have a residual. the same way that we have for y. And this requires software that, basically what you're saying is you need SEM software. Like, it's really just the capacity to predict more than one column at once. So like if you're coding your own in JAGS or STAN or something like that, you can do anything you want in those. But if you're working with conventional software, it has to be able to predict multiple columns. So visually, this is what it looks like. We're just doing the same thing on both sides of the equation. And when you put it this way, it's like, well, why wouldn't you do it this way? This seems a lot like, why would you make boxes over here but let these be circles? Well, because it's difficult to figure out what you get. So this is a table from this article that is cited several times throughout this presentation, because I hope that you read it. This article was a direct reaction of mine from reading something and thinking it was disingenuous and getting mad and deciding to write a paper about it instead of be mad. So what happened is there was a teacher's corner by the people who publish M+, when they first rolled out their Bayesian options. And they wrote an article comparing recovery of simulated data in the Bayesian model versus the maximum likelihood model, and they concluded in the article that the maximum likelihood estimates were biased and that the Bayes were better and we should all use Bayes from now on. Except when you actually dig under the hood, what happened is that in the maximum likelihood version, they fit smushed slopes. They did not pull apart the level 1 predictor. So the level 2 then becomes contextual, not between. And once you correct for that difference of whether it's between or contextual in the same way that I taught you, they're identical. And I was like, oh, hell no. And I got so mad after I figured this out that I pounded out a paper in like a week. I was just like furious. And I showed it to, this was when I was working at KU, I got the first draft done, and I showed it to our working group there. And they were like, can you please, for the love of God, just make a table or something, because I cannot understand this. And I said, that is a wonderful suggestion, thank you, and here is the table. So thank you to the KU RDA for that suggestion. Yes?
It just doesn't make, the whole thing doesn't make sense, because Bayes relies on a likelihood function that you have to define, so like why would they think it would be different to begin with at the end?
I don't know, but it sounded disingenuous to me, and I did not like that. So I reacted with a tutorial about how you fix it. So in this table, we have only covered the first 2 rows. I like your face, like, what? There's that much more? Yeah, do you remember? Do you remember Insecure Canyon? Right, we're all just sort of sitting down there like, I have to go all the way up there. No, the Dunning-Kruger effect. Yeah, I found this really great graphic. It's in the last video where they had like, after you get past the, I realize how much I don't know, there's Insecure Canyon where you just sit at the bottom and just look at all the knowledge that you don't have yet. And yeah. So yeah, and the reason, you can tell by the last column here, so what this table shows here is type of centering, so variable centered observed, constant centered observed, whether you have fixed effects and or you have adding random effects, and this is different ways of setting up the syntax in M+ to do that. Regardless of how you set it up, you get between if it's variable centered at level 1, and you get contextual if it's not. Okay, straightforward. Then you get into these situations where if I'm using ML estimation and I write the syntax one way with the fixed effect of a level 1 predictor, I get a between at level 2. If I write the exact same model using a different pattern of syntax, level 2 turns into contextual, unexpectedly. If I am using their new Bayesian estimation, the way that they have coded it, everything stays consistent and you end up with between at level 2 regardless. And if you're trying to do the usual structural equation modeling for single level data, then it really depends on what you do. So yeah, and none of the M+ guide describes any of this, by the way. They just show you how to fit the model and how to get numbers out, but there's no interpretations of anything provided. So that's why I have a job, is because I take the time to try to figure this stuff out and communicate it. So this is where we are. I want to show you this version right here. where everything stays consistent. So I am actually switching to Bayesian estimation to show you these. I am using uninformative priors though, so the results should be exactly the same as ML. So what Bayes does in terms of estimation is take your ML likelihood function, not the REML version, but the regular ML version, and add priors for all the parameters. But if you set priors that are sufficiently wide, like I have no idea what this could be, you figure it out, then the results converge to ML. So I should not be getting different answers because of that. So I have some tips here on how to tell the difference. My suggestion is to start with a model that has only X and Y in it, no other covariates mucking things up. And if you are fitting a model in which X predicts Y at two different levels is when this is relevant. So I would have for X a between cluster random intercept and a within cluster residual, and I would have the same thing for Y. The question is, what do you get at level 2? Is it contextual or between? So here's how I would recommend checking. If you fit a fixed slope as one alternative, and then if you change the relationship at level 1 to a covariance instead. Now this is not something you've seen from me this semester. This is something that you can do in path analysis or SEM more generally, is to just let variables be related to each other rather than have one predict the other in a directed fashion. If your answer changes between these two strategies, it must be contextual. Because contextual is the only option that controls for what's happening at level 1. Option A controls, option B does not. So if you get different answers, you're looking at a contextual effect at level 2, and if they're about the same, it should be between instead. Okay. So do you want to see what this might look like? Sure. Okay, here's what I'm going to do. I am pulling up the example 8A download packet. Okay, I don't have a handout. I've got files here. So I have data, I have the original input, I don't think I posted that much, and then I have output files. So I want to just walk through some of these. And the reason that I think that you should be able to use these without me is because of all the comments. So in M+, this is what the syntax looks like. It is just a little program where you write code, you hit a button, and the results come back as a text file. Yeah, it's not like a software package that you're used to where you can see the data and interact with the data. You can't. So M+ takes text files as data input in CSV format or like .dat format. And you have to tell it what your variable names are, what variables are in your analysis, and then what you want to happen. So in M+ syntax, make these bigger, all the comments have exclamation points. So everything in here is out like that. So you would tell it what the name of your data set is. These are names of all the variables in your file in order, and each one can only be up to 8 characters. Those of you who are taking SEM with me next semester, I use M+ in that course, and you will get much more better acquainted. So this is just like a very brief introduction. You tell it what variables you want to use. So this analysis is only going to be predicting language. This is the same data set that we used in example 4, where we're looking at, no, not example 4, excuse me, lecture 4, where we were looking at predicting language scores from verbal ability and other school characteristics. This is going to be an empty model for language only to get us started. Tell it what your missing data codes are. You tell it what your clustering variable is, so school ID in this case. And then any variables that are to be included only at one level or the other go on within and between lines here. Right now I got nothing. So note that each command ends in a semicolon, so it's very SAS-like in that regard. Analysis tells it what kind of analysis options you want. I'm going to do a 2-level model. I'm going to do Bayesian estimation because I know what's going to happen when I switch to ML for certain configurations. And Tech 8 is a piece of output that tells you what your priors are and it gives you convergence information with respect to that. So in multi-level syntax and M+, there's a model command, and then there is this % within %, and then the same thing with between. So you're literally writing out a multi-level set of equations in the way that you're used to seeing them in this course. So I did that deliberately because it maps on to how you would write the code. in M plus language, when you list a variable by itself, what you're referring to is its variance. So I have lang as my outcome here. In parentheses, I have a label for it so that I can save the result of that and make it do math on it. And then in the comments here, this is referring to level 1 residual variance in language. So this is my e-variance. At level 2 then, we have language in brackets. That means I'm referring to a mean or an intercept of that variable instead. That's my fixed intercept. And then I have language again, but now that is a variance at the between level. That's my random intercept. So all told, I have the models here that these came from. I did put this together for my own benefit and for yours to keep track of where this stuff came from. So these are the models that I have. Number 1 went with lecture 2, slides 10 to 11, which I have next. So this is an empty model. Here's the formula. So E is my level 1 variance, refers to my level 1 variance, excuse me. U refers to my level 2 variance. The actual variances themselves get estimated. So this looks familiar, right? Empty model? We've all got this one down. Absolute certainty. So one thing that M+ can do that the other packages can't is do linear combinations of not just fixed effects, but also variance components. So like if you do Stata Lincom or SAS Estimate or R, like Contest 1D, any of those, you can only do fixed effect combinations. You can do anything you want here. So I asked for it to additionally compute an interclass correlation. So what I have is a new parameter that I've labeled as ICC. The label for the level 2 variance I labeled as L int var, standing for language, and I have that divided by it plus the residual to make my interclass correlation. So this is regular flavor maximum likelihood in terms of the likelihood that's being optimized, even though it's within Bayes. So we should get pretty close to the same answers. So then we scroll and 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 we scroll. So this is one of the things I do not like about M+, is that you have to scroll 8 years to get to the output. And then you get finally to something called model results. In the model results, we have a within level and we have a between level. So variance of language at the within level, can you guess what that number means? 62? Yeah, that's my residual variance in language. This is analogous to a standard error in frequentist land. And then it gives me some kind of confidence interval, and I love this, significance with a star. I'm in Bayes land, and they're giving me stars for significance.
PPMP.
I'm like, I don't think we're supposed to use that word in Bayes land, right? What I can say is that my credible interval doesn't overlap 0, and then that's okay to say. So yes, we're going to ignore the stars. Between level means, any guesses as to what that thing is? The mean of language at the between level. What do I call that?
Fixed intercept.
Yeah, that's our fixed intercept. Now, why is it at level 2? Because when you write the equation, nope, come back here. Fixed intercept is in the level 2 equation. So 2 parameters at level 2, 1 parameter at level 1. That's how the output is organized. Come back. There we go. So then variance of language at the between level must be what? Between cluster variance in language at level 2, we would call that?
Random intercept.
Yeah, random intercept. See, it's like a vocabulary drill. And then new parameter, intraclass correlation. Y'all know what to do with that, right? What's an intraclass correlation tell us?
Ratio of between variance to within variance.
Between to close?
Or to total.
To total. Yep. So 23% of the variability has to do with what school these kids go to. Ta-da. So far, so good? Okay, that's why. Next model. So here's the answers, very close. Model 2, we are going to do the latent centering analog to a model that has student verbal at level 1 and student mean verbal at level 2. So the model itself looked like this. This specification tells me that level 1 verbal is centered how? This is cluster mean centered. So we are taking the verbal predictor and removing all of the level 2 variance from it manually as an observed predictor, and then we're sticking that observed cluster mean in and centering it at constant, so 0 means something. Instead of doing it with observed variables, we're going to do it with latent variables in latent centering. So model 2 differs by adding more variables to the problem. So mixed grade is a level 2 predictor, amount of homework is a level 2 predictor, verbal centered at 10 is going to be a level 1 variable that it carves up. So mixed grade and homework 2 go on the between because they only go into the level 2 model. I've done my centering here inside using the define function. Now at level 1, I've got some extra stuff. So we said that if I write language by itself in level 1, that's referring to its level 1 within variance. Can you guess what that is for verbal? And feel free to read the comment too, that'll help. Yeah, it's the same idea, just for X. So we are building the circles. That's what we're doing now. We're building these circles. We're saying, hey, M+, can I have a residual variance for X too? And can I also have one for Y at the same time? And then can I have verbal be predict language? So on in the M+ language is a regression slope, and it's Y on X. So think of on as an equal sign if you write the equation. So we're having verbal predict language directly at level 1. Then at level 2, I've added the corresponding verbal mean and verbal variance. So this one is going to be a fixed intercept for verbal, its mean. This is going to be a random intercept variance for verbal. And then I have my level 2 model predictors. So my level 2 covariates I listed first. And then I have verbal predicting language in the between model, which I've labeled as between, so that I can compute a contextual effect down here. So this is the exact same idea as cluster mean centering. The difference is that we are letting the model carve up my level 1 variable into its pieces rather than doing it via observed variables. This is also advantageous if we had missing data, because now verbal can have missing data on it the same way that language can. And so any case that has either variable can still be included. If I were doing this in the rest of the semester, what happens to cases that have missing level 1 predictors?
It will be short.
Yep, they're gone. And then you get into some weirdness in building cluster means. Because if you know that a certain person's going to get kicked out of the model because they're missing another level 1 predictor, should you include their level 1 predictor in building the cluster mean? I don't know. From a perspective of representation, yeah. But from a perspective of math and making sure that between and within are orthogonal, no. So this resolves some of that ambiguity as to what happens with missing data. You use whatever you have, and it figures it out in latent space. So this is the version that is directly interpretable. No matter how you set it up in ML or Bayes, this is going to be the within effect, this is going to be the between effect, and I can get the contextual as the difference like usual. So scroll, 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 down to the output. Here's my level 1 slope. So for every unit more verbal I have than everyone else in my school, my language goes up by 2.4. That is very nearly the same coefficient that we got out of the cluster mean centered model, 2.4. At level 2, verbal predicting language has a coefficient of 4. So for every unit more, and this is where it gets a little bit tricky, we used to say cluster mean. This is like latent mean. So we have to know how much variance this has to know what a unit is. Fortunately, that's in the model. That's the variance of verbal. So we could try to figure out what a standard deviation is and use that to contextualize what this slope means. But 4 is much bigger than what we got out of the cluster mean centered model, which is 3.6. So this is a common thing that you will see, and the reason that people would recommend that you do it this way. In the multivariate model, you're not assuming that the cluster means are perfectly reliable. In the observed variable model, you are. So this is disattenuated for differences in level 1 error. That is not the case when you do cluster mean centering. So the relationships at level 2 will often be stronger in a multivariate framework than they will be in an observed variable framework. Only at level 2, though. There is an article about that. Those ones, the Ludke, 2008 paper in particular was the first paper to really talk about this and describe why it happens and do a simulation about it. Extensions of why you would care about that in the context of multi-level mediation and interaction terms were covered by Preacher et al. As well. So the big difference is that we now have parameters for x in the same way that we have parameters for y. So we have a variance of verbal 10 at the within level, and we have a variance of language at the within level. They have different labels, though, because verbal's not being predicted, whereas language is being predicted, so it gets the term residual. So you have to get used to the language a little bit, but otherwise it's the same concepts. And here's my contextual effect, which is also stronger than what we got in cluster mean centering because the between effect is stronger. Yeah.
Yes, so Lisa, you said that now, for example, in the case of verb 10, we should take the square root of that variance to have the standard deviation. So what would be the interpretation of that 4 point something? Is that the change in our predicted outcome per 1 unit in terms of standard deviation for that variable?
It's not in terms of standard deviation, it's just 1 unit. But for you to
Okay.
figure out how much a unit is, I
Yeah.
think a standard deviation is helpful.
How?
So someone give me the standard square root of 0.52, please.
0.7721.
Okay, 0.7-ish. So standard deviation of this is 0.7. So a unit change in this variable is more than 1 standard deviation. It's like almost 1.5 standard deviations. So that helps to sort of explain like how much variability that is. Otherwise, you would have to rely on the original metric of the variable and think about it still as in terms of mean differences, but it's latent means. So this helps to give you the scale of what that coefficient is relative to.
Great.
It's this as x,
Okay.
not the original variable.
Okay.
Yeah.
Thank you.
Sure. So we have then, rather than the cluster mean box, we have a random intercept for x with an estimated variance that's carrying the between slope. We have a residual for x rather than a cluster mean centered box that's carrying the within variance, and then it gets the within slope. We still have effects of other level 2 predictors as well. And the same conditionality applies in thinking about means versus intercepts. What's the difference? What's the difference between a mean and an intercept in general terms?
There isn't one.
There isn't one?
There's something
Sometimes
is-
there's a difference.
If something is observed or being predicted?
Yeah, whether it's being predicted. Yeah, intercept is conditional. Intercept is being predicted. So we use the term intercept whenever this is the expected mean given blah, 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 blah is 0, right? That's intercept. Only in an empty model is the fixed intercept the mean, because then there's no blah, 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 blah to have 0, right? It's unconditional is another way to put that. So that's what M plus is referring to. The mean for verbal is literally the mean because verbal's not being predicted, it's X. But language is being predicted, so this is the fixed intercept for language, specifically when verbal is 0, which happens at 10 because I did the centering ahead of time to make sure that it stayed meaningful. Otherwise, it would be when verbal is 0, which might be weird.
Lisa?
Yeah.
The effects of homework and mixed grade on language, what would be the interpretation of those coefficients?
These are the same,
No, for homework, yes,
Yeah,
for
these
those
two.
two.
they're the same, exact same as in the results. These results.
Okay, but now those would be the effect of those variables on the latent version of language, or would be exactly the same interpretation as
Exactly the
before?
same because the latent version of language is in here. That's what these variance components refer to.
Great, okay.
So like the term latent is not new and different. It's just applied in a way that says we're going to treat X the same way we already been treating Y.
Great.
That's all. It's called latent centering because latent variables are the same as random effects, right? Same idea. So these two coefficients you would talk about in the exact same way. It's just that verbal has switched from being an observed variable to a latent variable at each level with an estimated variance. Yes, indeed. Okay. You haven't any strength for one more? Or no? I'll take a vote. It's 142.
Yeah, and I'm just
And you're just gonna,
not gonna, I'll do one of those things where I just like listen and not,
okay,
nothing really goes through.
nothing really goes through. Okay,
Other people want to.
Yeah, I can watch the record later.
yeah.
Yeah, sure. I'm gonna go out on a limb and say maybe we don't do the next one.
We don't need the next one? Okay, fair enough. Next one's random slopes, and it requires switching the thing. Okay, all right, it's decided. We'll do that, we'll do a little bit of that next time. So I have a couple models in here that we could potentially skip because it involves adding interaction terms. Because guess what? Here, I'll do that instead. No more models. What shape is this? Circle, very good.
Well, this is, never mind.
No, no. You said you weren't gonna listen, so I'm revising my process here. What shape is this? Square. Why are these different shapes? They're different things. And in the way of drawing these path diagrams, square means something that's real in your data set, and circle means something that is imaginary your model has to figure out. If I want to make an interaction term in my data set, can I do that?
Yeah.
I can make the variable, or I could have a star or a hashtag or whatever and fit an interaction term, right? Easy peasy. How do I do it with circle?
It's latent variable interaction.
A latent variable interaction. Does that sound easy or hard? Hard, that is correct. So latent variable interactions is how you would examine whether the between effect varies as a function of some moderator. That requires numeric integration if you're in ML land, or a more complex Bayesian analysis otherwise. So you will be likely be limited to the number of moderators that you can examine, whereas if this were an observed box and you're just making interaction terms, you can have as many as you want. So that's one downside to this approach, and that's why those two models are quite complex. So we can skip those if you want. But if you want to learn about latent variable interactions, that might be another class's job, not mine. Now it's 1:45. Okay, no more models, no more shapes. Any more questions? Okay, then I'll see y'all Thursday, I hope. Thanks for being here. Thanks for hanging in there. One more class, we got this. Yay. Thank you, Zoomers, too. See you next time.